From ContainerDays Hamburg, this video is proudly presented by Dux IT.
This is the session that probably is one of the coolest things that I've seen in the last 6 months or a year, and I've been working with even before it started to become a thing. Very quick introduction. I'm Alessandro Rossi, QB Alex everywhere, so you've probably seen me spamming on LinkedIn, spamming on GitHub, doing stuff. And I'm a specialist solution architect for RHEL at Red Hat, so I'm taking care of everything that is around the operating system. So operating system itself, management, automation, everything. And what we were going to see today, so we are going to talk about bootable containers or bootc-containers. So it's a quite rising project that started to skyrocket in the last year, and we will see, first of all, what it is. Second of all, we need to see it in action. So we will talk about the life cycle of bootable containers, so how we manage, how we deploy, how we maintain these kind of systems. And of course, there will be some demos. We have 3 demos for today. I was not proud enough and, not scared at all to challenge the demo gods, so the demos so jokes apart, for the sake of time, since it takes a long time to just download the images and play with the images, I just recorded those to make the experience fully enjoyable. And then, of course, we will wrap it up and take some Q&A. Starting from the beginning, so what are bootable containers? So the idea behind bootable containers is that we wanted to move the deployment and management of the operating system using something that we are familiar with, containers. So the idea in bootable containers is that you are not using a repository to update your packages, to make changes to your system, to update and upgrade your system, but you are using a container image. That is something that is potentially immutable and that you can, during the time, change by just rebuilding the image or changing the container file. We will see the internals in a bit, but the idea is to try and simplify as much as possible and use something we are familiar with to just manage our OS, deploy our OS, and especially, this is something that we experienced a lot also with customers at Red Hat, upgrades. Upgrades are sometimes painful, especially when going from a major version to another. And what is the idea behind the bootable containers? So what is the goal of bootable containers? Bootable containers, first of all, of course, we are talking about containers. So we have something that is repeatable, that we can have control on, because container files can be versioned. We can know exactly at any point in time what's inside that image. Images can be signed, so we can have an additional layer of security and being sure that this image is coming from our pipeline or our workflow or in general, our registry. And so we are trying to reduce those that are the risks that are linked to managing systems without not just the immutability, but the fact that potentially anyone is going to log into a system, maybe has some root credentials or something like this, and then the sprawl can start. Of course, we know containers. We are building application containers. So how these containers are different, we will see this in detail. But the idea here is that you can use exactly the same workflows and exactly the same tools that you use to build operating system containers. And the idea is, okay, you can use the same tools, so you can just enforce your rules. So you can basically start and getting faster even in the releases. Think of an application that is stuck on an older version of CentOS, Fedora, RHEL, or whatever, and you want to test it on the new version that is out. You have 2 ways. You can just ask for a new server or spin up a VM and just test it locally, or we will see that you can also use bootable containers to just test your application on the fly, both the compatibility of the application and also how this runs and how this performs in another system. And of course, having something that is streamlined, it gives the advantage of you build it once, so you create the structure before, so you already have maybe a pipeline, you already have multiple CI/CD environments, and you can just plug in the new container image that you will see. And what are the building blocks, of course? Because we are talking about containers, but what is the difference between the different, the standard containers that we know? Of course, we start with a dedicated image. bootc images are specific version of images that are basically based on the distribution that you are using. So it can be CentOS, Fedora, or RHEL, and it has everything that is needed for a final system. So you will have a dedicated kernel, you will have systemd, modules for networks, module for kernel, GPU support, everything. And we will see that you can either use the container as a container, so you can just podman run, docker run, or whatever run. In that case, you will use the host kernel, of course. But when you are going to install the system coming from a bootable container image, the system will have all the tools that are needed to run a system, exactly like a normal RHEL, Fedora, CentOS installation. Second one is the bootc CLI. bootc is an upstream project that is basically taking care of all the operations that are related to merge the container image world with the operating system world. It will be responsible for installing the system, updating the system, rolling back the system, because something can go wrong. And you can also use the switch option that is basically completely changing the base image you are using for your system. So your developers change the stack that they want to use, you can create a new container image and just replace in place the image that is there. The last but not least is the bootc image builder. For those of you who are familiar with image building tools like Packer or image builder for Fedora or CentOS, bootc image builder is dedicated to bootc images. So it takes care of converting the image from a container image to a consumable output. It can be a QCOW image, it can be a cloud image, it can be an ISO, or it can be a raw image that you can just then convert to something else. And again, this is available as a container. So bootc image builder is a containerized application. So if it rings a bell, it's a container. So if you have a Tecton pipeline, if you have a Jenkins pipeline, if you have something that can use containers, you can just inject this new step, and you have your whole pipeline that is going from the build to deploy your system. And we have something, and I'm working personally on something like this for Tecton, GitHub, GitLab, and all the integration possible. But, okay, we've talked about the building blocks, but how does it work? Well, everything starts from a container file, of course. We are talking about containers. It couldn't be different. But what is different is that, well, we build the container, so we are still in a familiar place. We push the container to a container registry. From here, we start to diverge a bit. So the image is in the container registry, and when you are deploying your system, what happens is, well, we need to convert the image and deploy it. So this is the first difference that is introduced by this process. So you need to create something that is consumable, hypervisor image or whatever. And when it comes to updates, I want to upgrade my system, going from CentOS 9 to CentOS 10, RHEL 9 to RHEL 10, Fedora 40X to Fedora +1. How do I do? I will start from a container file. I will change the base image that is responsible for managing the system, and I will be able to just redeploy my new image with the same configuration. And we will also see how does it work at the file system level. So what is preserved, what is changed, how it is changed. And up to now, it's fine. So we have our container, we know how to convert our image, and we will go through the different life cycle. So of course, we start with the build. We started from a container file. So the first difference that you can see here is that we are using, should be something like this. Well, it's not seeing, but you can see on top, so the base image is, of course, a bootc image. But everything else is the same. So you can add packages, you can add configuration script, you can add new tools that you have for your company. And this is the crucial part that we will see now, because what you can do is, okay, I'm working in a company that has very huge regulations. I need to have my monitoring agents. I need to have my logging agents. I need to have some security enforcement hardening that I need to do. Well, I can create a standard operating environment image that I can use and then provide to other tools, as a to other groups as a base image to start building what they want to do. So you can add a database, you can then add an application, you can then add anything else that you need, starting from something that is secured because it's an hardened image. You can run OpenSCAP profiles on bootc containers and bootc images. You can add configuration file, agents, anything that is required in your company. And of course, this opens up because you can have a single base image and derived image. And when it comes to updating, you can just update the first one, and all the other one can be updated in a cascading way. So you rebuild the new version of the base image, and all the other one can just go and follow. And of course, you have many ways to build, because again, we are talking about containers. So you have the Podman CLI, Docker CLI, any CLI, even the Mac embedded CLI. This is something that we know, okay? Podman is one of the containers, the container engines that we are most commonly using, even with Docker. There is no need for anyone else to just reinvent the wheel. We have the tool, it's working, so you can use it with any image that you want. Then we have Podman Desktop. We also introduced recently an extension for bootable containers, so you can just convert and create bootc images directly within the desktop, within Podman Desktop. And this is very easy, even for developer, to just create a new image, test it, and create a VM directly within Podman Desktop. And this is one of the coolest things that we are trying to work on, because we are creating and we are supporting all the integrations with most used CI/CD tools. I'm directly working on the Jenkins, Tekton, Ansible, and GitHub implementation. So at that repository that will also be available in the slides when we are going to share it, you will find some, I love to call it some sort of scaffolding that you can use to start creating your own pipeline within your environment, to just start and create an end-to-end experience from the build to the deploy. I have some examples also on deploying a Tekton pipeline to build, convert, and deploy a KubeVirt VM without touching anything. So it is something that we are working on, and we are working to make it available as validated content from Red Hat. And again, we are talking also about the deploy. So when we have created the image, we need to just convert it. So it can be a cloud image, it can be an hypervisor image, or it can be an ISO. Of course, ISOs are supported, so you can still use what you're used to. So you can embed a kickstart directly into the image and use the kickstart to make all the changes that you need. You will see that there is a new directive that is the OS3 container. Now it is called OS3 containers. Tomorrow probably will change in bootc, not tomorrow, but in a short term, because of course we are still polishing something. But the idea is packages will not be touched, because you cannot use the packages, because everything needs to be defined in the container file. So when the OS3 container directive is present, the package directive is completely ignored. But you can still add pre and post scripts. So if you had to install something when the system booted up or something like this, you can still do that in the pre and post scripts. And of course, when it comes to using different ways of updating, bootable containers also allow to do A/B testing easily, because we will see updating a system and changing the image of a system is just something like this. It takes seconds or minutes based on your connection, and you will have a new system, and you can start directing traffic to that system. Rollbacks, no more snapshot, no more backups, because rollback, and we will see, it's something that is taking seconds, and you will be able to do that in seconds of time. And again, it doesn't work just for minor updates. So it can be just a small change in a configuration file or a complete upgrade from one major version to another major version. And it doesn't change anything. And this is something that is very interesting, that is the file system layout. File system layout, so basically we have, at build time, everything is read-write, because of course we need to modify our system. When it's runtime, only /var and /etc are modifiable paths. USR is completely used by OS3 to manage all the file system layers. /var is the persistent layer. So if you need to add database data, application configuration, all needs to go there. /var is ignored during updates. So if you do something at build time in /var, this will not be propagated to the final system because we have var that is our persistent layer. ATC works a bit like the three-way merge that GitHub, CoreOS are doing. So if there are changes in ATC, changes in ATC can only happen via the tools of the operating system. You need to change the hostname. You cannot VI the ATC hostname file, but you need to use hostname.ctl. In that way, you can change the configuration at runtime. What happens is that when we are going to merge the new layers coming from the new image, the local changes will win. So if there is a conflict, the local changes will always win. So if you change the hostname in the original image, it will not be reflected on the running system. And it makes sense, because I don't want my server to change hostname from a moment to another. And when it comes to managing, of course, we are talking about containers. And again, containers have versioning. You can version your container, you can tag your container based on any criteria that you have in your company. And again, you can go from one environment to another by just running a set of tests or specific validation tests that can be integration tests, unit tests, or whatever on your application, and then just move the image to the next stage. Like this. So you start creating a first tag, you test it in development, well, you start going into the test environment. This is good. It can go to prod. So you can also manage all the versioning based on the tags, of course. And this can be iterated as much as you want. And when it comes to use cases, this is a very sensitive topic because, of course, bootable containers are not suitable for all the use cases. Because up to now, if you do a change on an image, you will need to reboot your system to get the new changes. There are work in progress to make a sort of soft reboot that will allow to do a user space reload of all the services and configurations, and you will be able to not reboot the system if no kernel updates are involved. But what are the use cases? Of course, AI/ML stacks. You just give your package to your developers with your model, serving, inferencing, training, whatever. You package it all. They just need to install it in their system, and they are good to go. When it comes to appliances or one-on-one application and to host, so you have an application, that specific application that runs to an host, you can embed that application either containerized or physically installed in the system, and you can just spin it up. This is one of the biggest use cases is Edge. Edge is one of the biggest use cases that you can find image mode / bootable containers in, because it is super suitable, because it can also be managed centrally with flightctl, that is flight control, that is an upstream project that is dedicated to managing this kind of devices with bootable containers on top of that. And again, you can also use it as standalone containers if you need to test it, if you need to make it work, and everything. In the community, what we have is we have some very good adoptions, both in the Fedora CoreOS space. We are converging bootc containers into Fedora CoreOS. We have the Atomic desktops. We have many distributions coming from Universal Blue, like Buzzite or Bluefin, that are very specialized distributions just for gaming, economics, studying, or whatever. And of course, we have some implementation also in Red Hat Enterprise Linux, because of course, it is also part of how we can deploy RHEL today. And RHEL AI is exactly the same. So we have, if you think about the previous slide, the AI/ML stacks, RHEL AI is exactly this, a bundled collection of what we have. So models, training, inferencing, software, anything that is needed to just deploy a complete AI/ML stack. But yeah, enough talking. So let's see this in action. So we have 3 use cases for today. So the first one, we are going to create a CentOS container, and we are going to convert it into a virtual machine on KVM. It will be a very simple image, HTTPD with an index.html. Second use case, we are going to update all the packages of the system, and we are going to deploy a new index. Third use case, something is going wrong, so we need to roll it back. And we will see all of these three. So starting from the first one, the flow is exactly the same. So I will start with a container file, I will build my container image, I will push it, and then I will convert it and deploy on KVM. So this will be the situation once we finish the first use case. So let me just quickly jump on the video. And again, we are starting from a container file. So this is public, so you can also go there, and I will add the link on the presentation. So we are starting from a clean situation. So we have our repository with our container file, our Podman desktop that is there, Quay used as a container registry, so we have everything clean, and we can just use it and start building. I will use Podman desktop because I really like it, and it's very easy and handy to use, even for demos or real-life applications. So let's start from the container file. So let's see what's inside the container file. It's a very simple one, no jokes, just a graphical environment, HTTPD on top of that, and an index.html. The index.html is a very simple one, so just basic HTML, and during the upgrade, we are going to use Bootstrap to just render a bit better the page. The use case is very easy and very simple, but the idea behind is that what we are going to do here, so you can see it's a very simple page. It can be done with any complex application that you are putting on your image. So let's start from the beginning. Let's build our fantastic image. So what we need to do here is, okay, we are going to select our container file. We are going to give it a name. So we are basically just trying to give it a name. I'm just building for my Mac. So of course, if you're building on a different platform, it will allow you to choose your platform. And the build is, of course, exactly the same. So it will just start fetching all the packages. It will just install all the applications that are needed. And this is the reason why it is recorded, because these parts take a bit of time, because we are talking about 3 gigs of image each and every time that we build something. And we are done with the image building phase. Now we need to push it, because we need to have it available in the container registry for further conversion. So we just push the image. So it is now in my QA, and I can just verify that everything is fine. I have my latest tag. I'm using the latest tag just for simplicity, but it can be any tag, any meaningful tag that you have. And as I mentioned, we have the bootable containers extension, so you can just convert the bootable container image directly within Podman desktop. So this is exactly what we are doing. So we are targeting our QCOW image, our container image, and we will select the virtualization guest. I will just change something here. I'm adding a configuration file because there is a format, a dedicated format to just add users, add a kickstart, add any customization that you want to add to the image. The process is exactly what you think it is. It will convert container images layers to OS3 layers, and it will apply it on the new QCOW image that we are created. So there is no magic. It's just about OS3 on the background. So if you are familiar with OS3, you will be super familiar with how the structure is created here. So I have now my QCOW image, so I will jump into UTM, because I'm using Mac, but it can be any virtualization, so very quickly going through the details. And I'm just mounting my fantastic image that I created. So I'm just ready to spin up my machine and verify that my web page is correctly working. And I will see that in some time, it will pop up and say, there are some software updates. And this is something that we are going to take care with the update part. So let's verify with bootc. So bootc can be used to check the status. So we will see that we have our container image, what is the digest of the image, so we can just double check what version of the image are we using. In this case, I'm just getting the IP because I want to verify that my web page is actually working. So I will just go into my tab and verify that we have a provisional index file. So it's not just plain HTML, CSS. Our developers need to still work on that. So just let me stop it here. OK. And let's get back to the second part. So our developers have started working on the web page. The web page is ready. We have updates for our system. and we are ready to update. So we are just going to start from here, and we are going to do exactly what we told before. We start from the container file, we change the content of the image, and we are going to pass from a simple and plain HTML to a Bootstrap-powered index. Oops. And this is exactly where we left. So we were here before. So now we need to update it. As you can see, there are some updates ready to install. So our developers want their system to be up to date. So we are going to do both. So we are going to re-update the base image. We are going to change the index.html. So we have, I just separated it to make it clear, but it is exactly the same exact content, but I'm just changing the name of the files that are inside it. And it is a different one. So it is now using Bootstrap. Again, the process is nothing new. I'm just going back to my Podman desktop, and I will just, of course, build a new image based on the new container file. And this is what's going to happen. I'm just selecting the update container file that will bring with it all the changes in the index. And here we go. We are just reiterating the build. So we will rebuild the image. We will, of course, push the new image. And we have everything ready. It will go, of course, during all the installation of the packages. This is why I cut the video. And now I'm ready to push it, exactly like any container image. The good thing will happen next. So once I have my container image in place, we will see how bootc is able to just fetch the new changes, check that there are changes. As you can see, I have it here a few seconds ago. So I just updated the image. And I'm back into my VM. So, okay, developers, you can just update your system. And I will check with bootc upgrade. There is an option to check if there is an upgrade. So bootc will contact the registry, fetch that there are differences, tell me how many differences are there. 1.3 gigs makes sense because there are also updates. And now I'm applying the update itself. The process is very simple. Fetching the different layer, applying the different layer to the OS3 layer, create a new entry in the bootloader with the new version pointing to the new OS3 commit. And that's how an upgrade works. It's not working just for an index.html. And here we go. We have our new image that is staged, and we can just reboot our system with the new image. You will see now that we have two entries in the bootloader, one pointing to the updated version and one pointing to the old version. Here we go. If you start thinking, you will 100% guess how the rollback will work. But we will see it in a second. I'm just checking. So my machine is perfectly working. No updates anymore. I can just double check that now. If I run the bootc status, I will see that I have a rollback image there that I can use to revert my changes if something goes wrong. So I'm just 100% sure that I have my new page. Here we go. So we have a new page of the application. And it can be a new version of a database, new version of an application, new version of whatever. And you will have it just right here in matter of minutes or seconds based on your internet connection. So if something goes wrong, what happens? We can just roll back. No backups, no snapshots, no pain. Because it can also roll back major versions. That is usually not easily doable with the upgrade tool that we have for distributions. So let's jump back and see how the rollback works. So we have our fantastic new page, but yeah, there are some issues, and our developers want to revert to the previous version. Nothing easier. There is a command for bootc that is called the bootc rollback command. We have our rollback image. Everything we need to do is just to issue our rollback command, reboot the system. Can you guess what is the operation that the rollback will do? It will just switch the order of the bootloader entries. Nothing easier. So it's not redeploying anything, it's not downloading anything, it's not changing anything. It will just swap the two entries, and you have your old version working. And again, if you want to re-roll back, it will just re-revert the change, because it has everything. All the layers are there. And we can just verify that this is really a matter of seconds, because there is no connection at all involved, you will just check that, of course, we are back on our previous version, and we are now serving our previous web page. Think this at scale, done at scale, on all your devices or servers that are using bootable containers. Matter of seconds. And this is something that really is great because, yeah, we have edge deployments or everything, but, you know, wrapping it up, the idea here is that when you are using bootable containers, you're using something that you already know, containers, and you know it very well. You can integrate it with all your tools. You can have an immutable way of deploying and managing your OS. And the upgrades can just go like you do that for the phone. They are over-the-air upgrades. There is nothing different from what happens from a phone. And the idea is that using this kind of images, you can really start standardizing all the builds and everything that you have in your environment, because you are starting from something that you know. It can be versioned, a container file can be versioned, you can know who put their hands on that container file, who changed something, and you will always know exactly what happened. I will just share with you a couple of resources here. At Red Hat, we created a series of labs where you can just freely, no registration, nothing required, you can just go there and start working with the labs, playing around with the bootable containers. And of course, if you have any question or something like this, even after the session, I will be around, so if you want to see something more. These are also the link that we will share with the presentation. And yeah, that's basically it. Thank you so much. And yeah, I'm ready for the questions.
If I understood correctly, the base image has packages like Python already installed. Is there also a minimal base image similar to Alpine?
Not right now. This is a very great question. Not right now, but there are work in progress to allow creating images from scratch. So you will be able to decide what you want to add into the image, starting from the bare minimum that is needed, of course, the kernel, all this stuff. But you will also be able to change the type of kernel. If you need real-time kernel, you will be able to build it from scratch.
Another question, what are some reasons for using bootc instead of Fedora CoreOS?
This is another great question. The idea is the difference between the bootc container and Fedora CoreOS is about the use cases that you have. While Fedora CoreOS was always dedicated to containerized operating systems, so having a sort of containerized operating system, with bootable containers, you have a fully functional operating system that you don't need any external configuration, you don't need butane for the configuration, you don't need anything more. So you define everything before, so when you are building your image. So this is the main difference. So it's mostly what is the final result. So with bootc containers, you have a finalized system, exactly like a package mode system. With Fedora CoreOS, you can still do some modifications, but it's a bit more jailed, let's put it this way.
What happens if the update fails to boot successfully? Is there some automatic rollback built into bootc?
Okay, this is potentially should not happen. So the idea here is that when they are, depending on what we are changing, of course, if you're doing a complete upgrade, it can happen, but there is no rollback, automatic rollback. What you can do is just reboot the system, select the other bootloader entry, and you will be back in your system. Of course, you can just do recovery, but there is no automatic rollback up to now. So that's, and of course, it is always rolling the development. So what I'm saying today can be different tomorrow.
Did you see the talk about dynamic OCI registries? It showed a proof of concept to generate image manifests at pool time. What do you think about combining the two concepts?
Absolutely, and it was the reason why I was attending that session, because we are trying to change the way how we manage layers for bootc, trying to make a sort of optimized way of combining different and similar layers and just really get the real delta of the application. So it could potentially come soon, not in the same exact way as we've seen in the dynamic OCI registry session, but there will be something that will be managed directly by bootc. So the thing is, yes, it will come.
I will merge two questions in one. Does bootc support any other distribution than Red Hat, Fedora, CentOS? Sorry. Like
It depends
Arc
on
Linux.
the other distribution. So if they plan to create some dedicated images and try to make it compatible with their packaging system and everything, why not? I mean, it's an open source project, so it's nothing strictly related to RHEL Fedora. Up to now, it's only available for RHEL Fedora and CentOS.
What's the best way to manage multiple bootc systems remotely? Do I SSH into them and run the bootc command to update them?
Well, here you have plenty of opportunities. So you can use your automation tool, Ansible being one of them. It can be any other automation tool. You can have a script that is, or a cron job that is just running on your system like once a month or once a week. Or you can leverage the flightctl project. Flightctl, as I was mentioning before, is an umbrella to manage all the bootc images in your fleets, so you can create fleets of devices and you can upgrade those at scale. Using you can use health checks, you can use update images, rollback images at scale. So you have many options there.
Does bootc run on Raspberry Pis? I would say yes.
It should. It should. Why not? There is no, we have some plans to make the bootloader agnostic. So this means that it will potentially also run on non-standard bootloaders like Android, but it's still work in progress.
Does the emergency bootc standard require RPM OS 3?
It doesn't require, but it's based on. So you can also perform potentially. It's the idea how it works is very similar. So when you are doing the upgrades, you are leveraging even the RPM OS 3 part to really create new commits and update the layers.
Is it possible to build bootc images from scratch?
I think this connects to the first question. It will be soon. Very good question. Why all layers have changed? And this was one of the reasons why I recorded the demo, because I wanted my developers wanted me to update the CentOS distribution. We had some packages there that were not updated. I intentionally deployed for the first time an old version of the image. It has a lot of updates, 1.5 gigs. That's why it just re-downloaded all the layers, because in the meantime, many changes happened in the system. Normally, it will be really something around 50 megabytes based on what you are changing in the image.
I will add my own question now. Why building bootc when sysex does most of the same job? I mean, you have those layers, you can change, you can update, you can roll back. So why building a new tool when there was an already existing tool that was already doing most of the job currently?
This, to be honest, it was the first thing that I had in mind when I've seen the same. Because I said, I already seen that. But yeah, you know, the CNCF landscape is so vast, and it opens up to many different projects. So jokes apart, yes, it's very similar. But yeah, this is, to be honest, and then this is our vision as Red Hat. The idea is to use this project and embed it into CoreOS, even for OpenShift container platform. So stay tuned, because probably the next versions of OpenShift, when they will be based on RHEL 10, they will probably leverage bootable containers for the core operating system part. So this is something that potentially can come up.
All right, we're over time now. Thanks a lot for this session. Thank you all for the questions.
Thank you so much, really. And enjoy.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.